To help us figure out how we calculate standard deviation, the first thing we want to do is let's try an example. I'm going to use page 82 as our guide. That tells us how to find the variance and the standard deviation for a population. So I'm going to use X just to describe a group of numbers. And the group of numbers I'm going to do are 1, 3, 5, 7, and 9. Now I'm trying to do an easy example, but I think I can demonstrate the concepts readily with that, and then we can build upon that. Okay, so if we look at the average here, we're going to treat that as a population. The average is mu, and that's the sum of all the x values over n. That's the total number, and we can see the total number in our little data set here is 5. So when I sum those numbers together, 1 and 3 is 4, 5 is 9, 7 is 16, and 9 is 25. 25, and there's 5 numbers, so 25 divided by 5 is 5. So we can see that mu is equal to 5. Okay, so we need to keep an eye on that. Okay, great. We can say mu is 5. We know n is 5 because there's 5 numbers. Now, if we look at this middle number here, we can see that's the average, but that's also the median as well. And that's good. Okay, so I'm going to build up a little table here. I'm going to take x. I'm going to take x minus mu. I'm going to take x minus mu squared. And I'm going to show you how to calculate standard deviation. And of course, we'll find variance as well before that for this little data set of numbers. So x is 1, 3, 5, 7, and 9. Okay, terrific. So what we're going to do is subtract each and every one from mu. And I know that mu is 5. So 1 minus 5 is negative 4, 3 minus 5 is negative 2, 5 minus 5 is 0, 7 minus 5, of course, is 2, and 9 minus 5 is 4. So we have all our numbers. Now if we sum up all those differences, we can see that those are going to sum up all the differences of x minus mu. And those are going to sum up to 0. Okay, negative 4, 4, negative 2, and 2, and then just 0. Okay, so anytime we take the sum of all the differences in any data set, they should be equal to 0. And this sum is sigma. That is the big Greek letter, sigma. And the little Greek letter sigma is what we use for standard deviation. This is all part of the Greek letters in the alphabet, since the Greeks did some of the earlier work. Okay. So now we're going to square each one of these because that's exactly what x minus mu squared is. Negative 4 squared is 16. Negative 2 squared is 4. 0 squared is 0. 2 squared is 4. And 4 times 4 is 16. Now we're going to go ahead and I'm going to take the sum of the squares of those differences. And we can see that 16 and 16 is 32. And 4 and 4 is 8, 32 and 8 is 40. So that adds up to 40. Okay, great. So now I can see that the standard deviation is going to equal the square root of the sum of all those differences squared over n. And that's the numbers, quantity numbers in the data set. Okay. So if we look at that, I can see that sigma is going to equal 40. Square root of 40, and we have 5 numbers, and that's going to be equal to the square root of 8. Okay, now if you want, you can say that sigma squared is equal to 8, and that's our variance. Okay, that's fine. Now if we look at the square root of 8, I'm just going to use my handy dandy calculator right here, and I'm going to take the square root of 8, and we can see that's 2.82. So we can see that the standard deviation is the square root of sigma squared, which is nothing more than what we did earlier with the square root of 8. And we can see that's 2.828. Oh, we'll call that 2.83, rounding to the nearest hundredths. So here is my standard deviation is 2.83. I can see that my variance, which is sigma squared, is equal to 8. Okay, so we just have to make sure that we can distinguish. Now this is the standard deviation. And this is my variance right here, and I'm just using Greek letter alpha and the alphabet. And remember just to look on page 82. So this would be page 82 on the textbook. Just reference those 6 steps. when you're finding out the standard deviation of a set of numbers. And that's the important calculation that we use in statistics. But before we take the square root, that will be the variance. So the variance, if the problem asks you to solve that, would be 8. And the standard deviations would be 2.83. So I hope that helps. That's an easy set of numbers, but that demonstrates the concepts. Go through, practice that, and then you can do something a little bit more complicated than that. Of course, you can use Minitab. Minitab is terrific, and certainly you can put those numbers into Minitab. We'll do all the descriptive statistics just like we did in class. All right, terrific. You have a great day, and I think that wraps this up for standard deviation.